Okay, it looks like the amount of attendees coming in has stabilized, so we'll go ahead and get started. Just real quickly, before we get started, if anybody has any questions, just go ahead and log those into the questions window, and then I will answer all of those at the end of the webinar. So, okay, so hello everyone. Thank you for joining us today for Webinar Wednesday. Today, we will be going over the conversion tools available within Creo to turn solid parts into sheet metal parts. This is going to be a pretty short, sweet, and to the point webinar today. So we'll just go over the agenda here quickly. So as stated, we're going to go over and demonstrate the conversion tools inside of Sheetmetal. So we'll start with an introduction to myself and to PDSVISION US. And then on our topic overview, we're going to start out with the beginning of the solid part conversion process, and then we'll go over the conversion options and tools. We'll then move into a live demo to show off all the conversion features that we go over. And then after that, we will have our Q&A time, and then we will call it a day. So first, we'll get the introductions out of the way. My name is Tyler Walton. I am a technical specialist with PDSVISION US, and my background is in mechanical design, additive manufacturing, and portable CMM operations with things such as a ferro arm, with a focus in the point probing and laser scanning areas. And just a quick rundown of our company history. So we were founded in 2006 as Boundary Systems in Cleveland, Ohio, and we've continued to grow throughout the years. And in 2014, we expanded into South Africa. Then continuing through the 2010s and 2018, we were acquired by the PDSVISION Group. And then more recently, we've gone through our own rebranding, and now we are PDSVISION North America. So some information about our strategic partners. We are the biggest PTC global reseller in their software solutions, and we also offer professional training, consulting, and run help desk groups for PTC related issues as well. And though PTC is our largest strategic partner, we do work with a variety of other partners as well, such as ZW CAD, Keyshot, Moldex 3D, just to name a few. And here quickly, I would like to just go over the digital thread concept. So this is a concept that we as a company like to use. It helps us to lay out a grid of what your needs are and then look to see what options line up with your base level needs. So we can then offer other solutions that would align with your strategic goals so that as a company, you would have that single point of truth and have that total connectivity throughout all layers of the company when it comes to your product and processes. This next graph here, this is just a better visual to show what I was just talking about on the previous slide. And here you can see with the digital thread concept in mind, how your data and parts flow through a well set up system. So you can see here with when we're in our planning and sales, and then we move through to our design concept, then into the detailed design. And then as we come into our as-built, our production planning and our actual production, and then flowing straight into our as-maintained blocks, so your delivery operations and then your end game service. And basically what this is it is a philosophy that leads to reduced time to market and reduced downtime, reduced costs, and really just an overall increase in efficiency. Now, on to the fun stuff. So we're going to get started into, what is sheet metal conversion inside of Creo. So sheet metal conversion tools allow users to convert a Creo solid part or an imported step file to a sheet metal part inside of Creo. And so just quickly, the conversion path to allow you to do this is in Creo, in your solid part, underneath your operations tab, you go ahead and click the drop down tab there and scroll the whole way to the bottom. And there's an option that says convert to sheet metal part. Once you have clicked this option, you're going to be greeted with a new ribbon that's going to come up, and it's going to give you all of the options that are available for your conversion. And as you can see here in this detail, this is just a blowed up section of that ribbon, and all this is doing is showing you the conversion types that we're going to be going over today. So just very quickly, you know, kind of a 1,000-foot overview. We have driving surface, we have shell, and we have an empty body conversion type. So if we look below here in our graphics, so this is a driving surface example. So as you can see here, this is the solid part that was modeled before it was converted into sheet metal, and then using the driving surface conversion type, we were able to convert into this sheet metal part here. Now with the shell type, so this is an example of a solid part that was designed, and then using the shell conversion, we were able to meet the needs of that down here, creating this shelled part, excluding surfaces and assigning a thickness and creating that. And then our empty body feature, which out of all three, the empty body feature I believe is the most interesting to myself. It has two separate functions, which we'll get into a little bit later, but as we're seeing here, the biggest thing is that this allows you to have a solid feature, a solid part, and then you're converting into the sheet metal, and it allows you to craft sheet metal geometry onto the actual solid part without editing the solid part. So as I said, we're going to dive into these a little bit deeper in the following slides. So I think what's important, and I know that this is kind of just very common knowledge to those of us that use Creo often, but I think it's a strong starting point, and that is, what is a solid part? So a solid part is going to be the default part file that is made within Creo when selecting new part. If you were to not want a solid part made from the get-go, you would have to manually select a different sub-feature to the right of that view, or to the right of those options whenever creating a part. So whenever you go into Creo and you make a new part and you just hit OK and open, you're going to get a solid part every time. So once these solid parts are then converted, these solid parts are now able to use all of the available options that you would get with your typical sheet metal parts. Just some simple examples. You'll be able to add corner cuts, relief, additional bent walls, rounds, bend lines, and then creating flat patterns. So we see here underneath on these graphics, just some very quick examples just to show. So this box was just designed, it was, you know, just a very simple box, solid, no cuts on the corners. And then when converted into sheet metal, this allowed us to add our corner relief here and our edge cuts, allowing this box to be unbent and allowing it to have a flat pattern made. And then also with this, you know, rebending the box, it allows us to also add in additional bent walls and bent features to that previously solid part. As you can see here on the right, this part here, it's just a little bit more of an upgraded and modified part of the basic part that we have up here in our top left. As you can see here, we've added some rounds, and obviously it has been converted, and then that allowed us to give the flat pattern feature to this model. And then you can see here that these dashed lines in these areas that are marked here, that is actually your bend lines. So when you unbend, it's going to automatically craft bend lines for you, and allowing you to, if you would need to put this model on a drawing, you could dimension directly to those bent lines, allowing you to control exactly where you would want those lines at. So we're going to go ahead and dive a little bit deeper now into the specific conversion types. So we're going to go ahead and start with the driving surface. Now, the driving surface is the conversion type that I think is probably the most common used. And so with the driving surface conversion type, you know, this is great for converting parts that are already designed to mimic sheet metal parts, but in solid form. It's also best when the parts are not too complex. Complexity in trying to convert a part is typically something that you want to try and avoid. The simpler, the better. And then, it's ideal if the parts have universal thickness, though thicknesses can be made uniform during the conversion process. And what I mean by this is, say you have a bracket and the top of your bracket is a 1/2 inch thick, the bottom of it is a 1/4 inch thick for some reason. When you go ahead and convert, the entire part has to be a uniform thickness. And so what the program is going to ask you to do is it's going to ask for an initial driving surface, and it will then pull the data from that driving surface as to how thick is this surface, and then it will uniformly apply that thickness throughout the entire part as you select your additional surfaces and complete the conversion. So after converting, you have features on your part such as pre-designed rounds and chamfers, cuts. These are all going to transfer to the new sheet metal part seamlessly. You won't lose these small features. So as you can see here on our top left part, we have some chamfers around our hole cuts here. Obviously we have our holes, our cut in the back. All of that has transferred over into this new part. So you're not going to lose those features. And then you're also, once converted and you're in there, you're going to be able to add additional features as well, more cuts, chamfers, and etc. This is also going to allow the user to create a flat pattern of the previously solid model, as we saw on the above slide, which was actually a flat pattern of this exact part. And then, this is also allowing just all of the sheet metal functionality to work with your converted part. As I said, your additional walls and bends and cuts and etc. So now we'll go into the shell conversion type. So the shell conversion type it's great for converting solid parts that need to be shelled, but then also have to have the ability to be unbent. Just a common example of parts that might be viable in this would be HVAC parts, allowing them to be designed to be unbent so that they can be cut out, manufactured, and then bent up to what they are needed to be. So this feature allows the user to select the surfaces that you want to exclude to make your shell, and then assign a uniform thickness across the part. And it is very similar to the Creo modeler shelling feature that's available just in your standard Creo modeler. And then, so with the shell though, after conversion, the part has to be given a designated way to be cut so that it can be unbent. So, as you can see here in this part, it has been shelled, but there is no feature here showing a cut or a separation. So if you would try to do an unbend feature directly after shelling, it's not going to allow you to do it. It's going to give you an error. And so there are ways to go in and add that feature so that the unbending is possible. And so possible examples, you have your edge rip, your rip connect, your edge bend, your corner relief, countless other options in there to add and to take away from the model. So complex parts can also be converted and shelled. I have seen some complex parts be shelled, and definitely doable. It does require more work though from the designer, and I mean what I mean by this is if you have a complex feature and you shell it out, you have to understand where you want to put your rips, your edge rips, and your corner relief, and all of that. So that way, when it is unbent, you're getting the final product that you're looking for. Because Creo does allow you to do some commands that might not necessarily get you what you're looking for in the end, though it does allow, the program allows it to happen. So you just kind of have to have that mental clarity on what you're looking for and what you're trying to get out of the end product. So now we're going to move into the empty body conversion type, and the empty body conversion type, as I said, this one I find personally very interesting. So this conversion type has two functions, and one is very simple, and the other one is a little bit more, I wouldn't say complex, but nifty. So the very simple feature is that, say you have started a file in as a Creo solid model. You have yet to add any geometry to the file, but you've gone through, you've added your parameters, you've added your part numbers, you've added additional information, detail, whatever into the documentation. And you decide, well, maybe this part needs to actually be in sheet metal. This allows you, the first part of this allows you to just simply go in on an empty model without any geometry, do the convert empty body, and it's going to convert the part straight to sheet metal so that you have all the functionality of sheet metal from the get-go. So that's very helpful. It makes it so that you don't have to, do double duty in adding information about a part twice. The second feature is what we're showing here in these graphics. And so what this is you would be adding an empty body feature into your model tree. And what this is good for is it's great for parts that need both solid and sheet metal functionality. And this empty body is going to allow you that when you hit the conversion tool for empty body, it's going to convert just the empty body part. It's going to keep the solid part totally unchanged. It's going to be basically two parts in one part file. And so after you've gone through your conversion, after you've clicked your conversion option, it's going to ask you if you want to convert your empty body feature, which you'll say yes. Once you do this, you're going to have the availability of all of sheet metal, everything that you can do within sheet metal, you can add it to this solid part. And then the great thing is that, as you are adding these things, all of the sheet metal functions will not affect the solid part that they're attached to. So you want to go ahead and add in your bends, you want to add in additional planar features, you want to unbend all of those features. All of that is very possible, and it will not touch the original part. And then when you're in the inside of this file, it very, very easy to tell, what is the solid file here and what is the sheet metal. So the solid is still going to come through as your gray, and then the sheet metal is going to come through as the sheet metal green. And an important note here is that this empty body conversion type is only available from Creo 7.0 and up. So we're going to go ahead and we're going to move into our demo, or multiple demos, I should say. So we do have a demo to show off each conversion type, and then I do have a demo also walking over how to convert a step file. So we're going to start here. We're going to continue to use the same models that were shown in the webinar. So this is just going to be a very basic driving surface conversion. So again, we have our Creo solid part. We're going to go ahead into our operations tab and click our drop down and scroll the whole way to the bottom, and then we're going to click our convert to sheet metal tool. So now what this is doing is, here's our ribbon from our previous slide showing our types. We're going to keep the driving surface selected. We're going to go ahead. Our driving surface will be this bottom surface. And now from here, it's going to ask, okay, well, there's multiple other surfaces here that we need to include. How do you want to go about it? So we want to go down here and hit our include surfaces tab. From here, holding the control key, we're going to go ahead and click through our other features. And now it's referencing the whole part as being referenced. And we do have some miscolored areas here on the rounds, which we'll get to in a second. So if we go ahead and click OK, it will give us a quick error. And basically what this error is it's coming up about these areas here, these rounds. And what it's saying is that we're going to change the rounds to more match the bend function inside sheet metal. So we're okay with that. We're going to go ahead and hit OK. So now, as we can see, this part has been converted to sheet metal. We now have all the functionality. If we wanted to go ahead and unbend, we could do that. Everything will function now. So now we'll move on to our shell. So again, using a model straight from the webinar slides. Again, shell is a solid model. go ahead up here, hit our operations, convert to sheet metal. Now, instead of driving surface, we're going to click shell, and it's automatically going to detect that this model is what we want to shell. It's going to ask us what surfaces do you want removed. So we're going to go ahead and we're going to select our bottom and top here. And we're going to give it a thickness of 1. Okay. So now we can see that we have the shelled feature. It's given that uniform thickness across the entire part. But as we said earlier, if we try to unbend, it is not going to allow us because there is no feature on here giving it an area to unbend from. So we're going to go ahead and delete that. So just as a very easy example here, under our rip tool, we're just going to come in, we're going to sketch a rip on that surface. We're going to make it very simple, just a straight line, top to bottom. Click OK. So now what this is doing is it might not seem like there's a rip here, but you can see that now this surface is split into 2 separate areas, and that is designating that that is a rip. So now if we go to unbend, the part unbends. So now we will move into our empty body. So as we can see, we have our solid feature here, and this is a part that we don't want to alter. Say that this seems to be a pretty heavy part, some kind of an industrial cover, and we want maybe some kind of a sheet metal feature top and bottom that would allow us to align into some slots to make it easier to hold this thing in place while we're putting our bolts in. We would actually come up here into the body tab and we would click new body. And so I have some empty bodies in this model tree already. That's why it's stating for, typically you're going to get new body 2. So we're just going to go ahead and click OK. Now from here, we're going to go to operations. We're going to convert to sheet metal. And it's going to ask us, do you want to convert to empty body 4? And it's already going to pre-select empty body for us. So we're going to go ahead and hit OK. So from this point, now we have all the functionality that we can add to this part. So we're going to go ahead and add a planar feature to this surface here. We'll go ahead and add a center line to make this symmetrical. And we'll go ahead and add a reference here on this plane. And we'll just keep it extremely simple. We'll just add in box. Let's call it 7 high, 7 wide. Hit OK. So now you have the ability to assign a thickness. Let's just keep it at 0.5. Let's flip the direction so that it's in line with that top plane. Hit OK. So now you can see we've added a sheet metal planar feature to this solid part here. And now this gives us the functionality. We could come in, we could add a flat, a flange, and then, different shapes. Let's say, let's keep it roughly about the same as what we showed in the webinar. We'll do a T, and we'll keep that at 90 degrees. Call that 5, call that 3. All your options in here to change things as needed. Go ahead and hit OK. And then say you wanted to mirror that exact piece to the bottom. Go ahead and under editing, go to your mirror across that plane, and there you go. Just a very simple rundown just to show, you have all the functionality of sheet metal available to you in here. You just need to just go about adding, your planar features and then working from there to add what you would need to add. So, and again, this is the empty body, and it will automatically convert when you have an empty body inside of your model tree, and this is what you're going to get. So lastly here, I'm going to run through converting a step file. So it is worth mentioning that when you import a step file, into Creo and create a new part, you should be able to run through and just use some of the conversion tools that I just showed you to actually convert the step file. What I am going to show you now, though, is an additional way to convert this. If you bring your step file in and for some reason it is giving you fits, it doesn't want to convert for some reason. This is an additional way to go about converting and getting the part that you want. So what we're going to do here is we've imported the step file, and we're good to go here. So we are going to come up to our Get Data tab. Oh, I'm sorry, apologies. We're going to go to our model intent, and we are going to publish geometry. Now, what this is going to do, it's very similar to the driving surface, where we are going to pick our individual surface sets as our outside surfaces. And we're going to click OK. And then from here, we'll go and we will make a new sheet metal part. We'll call this sheet metal step. Okay. So up here in our Get Data tab, we're going to click on Copy Geometry. Now we want to open the step file that we just copied everything from, that's in session. So we're going to open here in session, step 1. And then up here in the placement tab, we're just going to go ahead and click OK. Now here in the Publish Geometry Reference box, we're going to click, and we're going to see that our step file that we copied over is going to show up here. We want to select the part, and the easiest way to do that is if we come down here to the bottom left and we expand the footer and we click on the Publish Geometry ID. That's going to highlight our entire part up here. So now we can click OK. And what this is doing is it's copying just the surface chains that we brought over from the step file. Now, in order to add thickness to this part, you can't use thicken. It doesn't work with this. So we would actually go into our Walls tab and we would do Offset. Now it's going to ask us what surface do we want to do. So we want to make sure that we're selected in that box, and then we can come down here. And since this is a chain, we can just right click and it's going to select the entire chain. Go ahead and click on that. And then we're going to keep our offset at 0. We're going to change our thickness. Let's give it a thickness of 1.5. Click OK. So now we'll go ahead and we'll hide the original boundary chain, and we can see that we now have a sheet metal part from the references from the step file that we imported. And it bends. We have all that functionality in here now. It's actually just like it's a sheet metal part. And then just a quick other example here. If you wanted to remove some features like one of these holes, you can actually come up to your flexible modeling and you can go into remove. Now, since this part has been thickened, we're going to use surfaces, but you can remove the features as well when it's still a boundary chain if you use this quilt boundary chain feature here. So under surface, we are selected in our box to remove surfaces. So we're going to come in, we're going to select all of these internal surfaces of this hole, and boom, it removes it. So just some neat features, just to show, as I said, this is an additional way to get a step file to convert to sheet metal if the previous 3 that I've gone over, or really 2, don't work or they're giving you fits. This is just an additional way to go ahead and convert these. So, okay, so we are done with our demos. So now we'll move on to our questions, and I see that we have one question in our question box. Just give me a second here to read over it. When converting to sheet metal, can you invoke a sheet metal start part to ensure conformance to defined standard material bend tables, radii, etc., that you would normally get when starting with a sheet metal part. Yes, I believe so. That is something that I would have to do a little bit more research into. But yes, I believe that is possible. And that is something too, Walter, that I can get back to you if you would want to reach out after the webinar and give me an email. I can reach out to you personally and answer that question when I get that information. So the second question here, can you change the size of a feature from an imported step file, such as a whole size? So in my experience, the best way to go about that is if you would want to change the size of a feature, such as a hole, the best thing would be to fill in the hole that is there and then to go back in and to do an extrusion cut inside sheet metal to get the feature that you're looking for. Okay, great. Walter, I see that you responded, and like I said, just get with me. My email will be coming up in a couple of slides here, so just go ahead and rip that off that slide and send me a personalized email, and then I will communicate with you and get you that information. So if anyone here on this webinar, is interested in our training capabilities, if you would want to learn more about sheet metal inside Creo or any of the other Creo related features that is offered, then all of our webinar topic presenters, we are all certified trainers, and we love to go through our deep dives into these topics. And as far as training availability, we do virtual. If there's COVID restrictions where you're working, or if it just works better to do a virtual class, we also have some training centers located around the country that we do in-center training, and we also have the ability to come on site to your work site to do training for you as well. And if you have any interest, please reach out. Check our website for our full schedule of classes, or if you would want to reach out personally to me or any of our other webinar presenters, then feel free. We can inquire about specific classes for you as well. And then, as I said, if you require any further information, as I said, my name is Tyler Walton, and that my email address is twalton@pdsvision.us. For any sales related questions, please reach out to our sales at sales@pdsvision.us. And by all means, please visit our PDS Vision US website and continue to check us out on YouTube. We do present webinars every Wednesday at 11:30. They tend to run a half an hour to 45 minutes long, typically. And we try to have a varied amount of information that we put out on our YouTube channel, and it's always great when we have a decent amount of attendees on our calls or on these webinars, and providing us with the questions, so that way we can be proactive and answering these things for you guys, and garnering some interest, and if we finding out if there's anything else that we can do to assist and to help to train. So yeah, just please, if any interest at all, reach out. And that wraps up our Wednesday webinar. So, again, thank you everybody for attending today. And again, any additional questions or information needed, please feel free to reach out. Thank you. Have a good one.